So today I want to talk about writing the actual article, Next Generation Science with Jupyter. And just to kind of say what I mean a little bit here, I'm going to go ahead and say in advance that many of these slides are from Chris Holdgraf. So you guys may not know Chris Holdgraf yet. He's coming this weekend, I think. But you may know him already because on Slack he has added all of the wonderful party parrot emojis. So for now we can say that Chris is party parrot. And he's a really big expert in this field, and so I think this is a really great opportunity. If these are things you're interested in, him being here next week will be a really great chance to hack on some of these ideas if you're as excited about them as I am. Okay, so with that being said, I want to talk a little bit about what I mean when I say that we're writing the actual article. And to think about this, I want to go back to this quote that Ariel actually showed in his introduction to this whole wonderful experience of NeuroHackademy. And I'll just read it out for you again. So the quote is, "An article about computational science in a scientific publication is not the scholarship itself. It is merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures." So this is something that I think we all here realize, like there's a lot that goes on beneath what we see as a PDF. As scientists, you've probably gone through the whole process of writing the code and making sure it all runs and then thinking about a paper. So how could we get it so that we are able to do an actual article where we have the software development environment, we have the complete set of instructions? What would it mean to write that? And so I think one really promising example here is a Jupyter notebook. So I want to talk to you a little bit about Jupyter notebooks and some of the other things that come out of the Jupyter ecosystem. And the reason I say it's a really promising example is because just looking here, and as you've seen in many of the tutorials so far that have used Jupyter notebooks, they're this really cool system where you can alternate explanatory text, code, and then figures, which could optionally be interactive. So it seems to have many of these pieces that we think about when we say what would be an actual article. So in this talk, I want to talk a little bit about Jupyter notebooks, how we could make them better, or at least use them better, and what that would mean. Jupyterlab, which is something I know a few of you have already seen because Ariel set up a Jupyter Hub for this course, which is really cool. And I'm going to talk about why Jupyterlab is amazing. And then I want to talk to you just a little bit about Binder, which is something else that's come out of the Jupyter project and shows real promise in kind of bringing all of these steps together. So first things first, what is Jupyter? So I've said Jupyter Notebook, I said Jupyterlab, I said Binder's a Jupyter project. What is Jupyter? That's really hard to define actually because there are way more projects than just those three that are under the Jupyter umbrella. So I really love this definition Chris has given, which is that Jupyter is a community of people and it's an ecosystem of open tools and standards for interactive computing. So one thing that's really sort of amazing here is that because it is this community, most people are based in very disparate institutions all around the world and in many different fields. So there are neuroscientists here, there are also people who work in finances and lots of other fields, geological sciences, that you can develop these very general purpose tools that allow us to really do science fundamentally in this kind of interactive way. And because you've got this community with these diverse interests and they're bringing together all these different sources of expertise, that enables them to create things that are language agnostic and modular, and it empowers people to use other open tools. So one of the misconceptions that I often hear from people is they think, oh, Jupyter notebooks, and that's all just for Python. That's the only way you can use them, but it's not true. So Jupyter itself is actually originally taken from the Ju was for Julia, the Pi was for Python, and then R for the R programming languages. So from the start, it always supported all three. And since then, people have come in and added what they call kernels, which means that you can then bridge into multiple other languages. So there's an Octave one for folks who love MATLAB. I think if you set your licenses carefully, you can do MATLAB itself. There's many languages that you can now use all of these tools for. And that's possible because they are modular and open. So I think that's really cool right away. And one of the things that they've made in this context is the Jupyter Notebook. So the Jupyter Notebook, again, has this very basic framework where you can have interleaved text, code, and outputs, and they, again, can be in over 100 languages at this point, right? Whatever you're comfortable writing in, it can be in a Jupyter Notebook, and you can share it with your colleagues. So we're getting kind of closer to this idea already. So I really kind of want to walk through. So I told you that the two things that are missing in most scientific publications are the complete set of instructions and the complete software development environment. So the way Jupyter is set up is that you really have the complete set of instructions. So it's really designed around open source languages. So that's why, Python, R, and Julia were kind of the backbone in the beginning. So all of these languages are available already. And then it allows you to capture all of these steps. So as you're running it in a web browser, you can do the text, the comments, the equations, the actual lines of codes. You can have all the output. So this recipe for your science can all be in one place in a way that's not really possible when we think about writing an article right now. The other thing is, because these are all plain text documents, you can put them online. You can version control them, so they're not binary files. The version control diff is a little messy, but that's something that a lot of people have been thinking about and working on. But you can go through and you can see, how do I track when I made this change? You can test your Jupyter notebooks, so you can run them through and assess whether or not the output is what you've recorded it as. You can do lots of really cool things that, if you are familiar with Git and GitHub, are very important, version controlling our work. You can do it in this kind of environment. So that's really amazing as well, that we have this instruction, and not only what we need to do, but the order in which we figured it out. Okay, so this seems amazing. This seems like a really cool framework. What are some things that we can do with Jupyter notebooks? So again, we can interleave these code, text, and figures. We can add in these additional kernels, and here I've linked out just some of the kernels that are available, and you can see it just sort of keeps going. So if you're interested in almost any language, it might be in Jupyter already, or you can add it yourself. And then one other thing is that you can create outputs in a variety of formats. So you have this format of the Jupyter notebook itself to start with, but you can also convert it to HTML, to PDF, to Markdown. There's ways to get it into reveal.js slides, really pretty slides if you like slides. So there's quite a few things that you can actually get from a Jupyter notebook. And you can also do magic. So how many people are already familiar with Python magic or Jupyter magic? Cool, okay, not everyone. So I wanted to show you this. So this is just a little, it's so small. Okay, better. This is just a little toy notebook I made just to kind of show this idea of why magics can be really cool. So in this first cell, so let's just restart and clear output just to be sure we don't have any state. Great, okay. So in this first cell, I'm importing Seaborn, and I'm just doing a really basic plot. Dog plot, it's a great plot. So if I execute that cell with Shift-Enter, nothing happened, right? Or nothing happened that we can see. So if you've done this in a terminal, you may remember that what's missing here is import matplotlib.pyplot and then plot.show. So there's this magic called matplotlib, where you can have access to kind of set this plotting for the whole rest of the environment. So I can say magic matplotlib inline, and now if I execute the exact same command, it shows the plot, right? So this is really cool. So normally what you do is you set this magic at the top of your notebook, and then it would apply, and you'd have access to all of this. Another cool magic that is super useful is called time it. So the idea here is that if you're trying different options and you really need something to be really quick, like maybe your calculations are taking much too long and you really want to figure out what's a faster way to do it, with this time it magic, you can actually time how long it takes to execute a calculation, and it'll do it over repeatedly, so that you can actually see on average about how long it takes. So this one, if I remember correctly, takes a few seconds to kind of get the average. But while that's running, Yeah, here we go. So it's 11.4 microseconds plus or minus 364 nanoseconds per loop. So it tells you how many loops it ran, and it allows you to go through and see, okay, how long is this actually taking? What if I try this other option? Is it faster? Can I cut it down? There's also load, which I never knew about until recently and love. Basically, so this is some JavaScript that Pierre Bellec wrote for a library he has called BrainSprite. And if I wanted to mess with it, so let me show you what it actually looks like. If I went, what I could do is go to this site, see that it's a ton of JavaScript, and then be like, okay, well, I can copy it, and I can try and find my tab again, and I can paste it, or I can just do this load magic. I run it, and it immediately replaces the cell, so it turns the command into a comment, and it replaces the cell with that code that was already on the other page. So it makes it really, really easy to load in large scripts that you want to have access to. Another thing that Tal talked about, which is really cool, is this idea of interactivity. So folks have been, it's not a true magic command, but I think it's pretty close to magic. They've been creating these widgets, which are different ways that you can design interaction in the Jupyter Notebook very easily. So here, for example, I have a little text box I can increment, and when I increment it, the slider changes as well. So I can do like 100, and it'll jump over. So this is really cool if you have stuff that you want to change as you vary values. So Tal just showed this actually, but this is very easy. It's as simple as like import widgets, and then there are different widgets that you can choose from. They have right away. So there's a lot of really, really cool stuff there in the magics. And I'm only showing you 4 here. Don't take this to be the only 4. If you Google like Jupyter magics or IPython magics, there are like over 30 magics that you can do. There's all sorts of stuff. I think these are fun and interesting, but there are many, many more that are worth looking into and knowing about. All right, so let's take a step back. So I said this was about writing the actual article. I've just told you about Jupyter Notebooks. I've told you you can literally do magic with them. But how does this help us in our process of writing, the complete instructions in the complete software development environment? So there's a researcher named Jane in the world somewhere, I'm sure. And she has written a paper based on her experiments. What she'd like to do is to make it available so that anyone can reproduce, check, and improve her calculations. So she wants to release the results of her study into the world. The first step, and what I think Jupyter Notebooks are really promising for, is she describes the experiment as a notebook mixing prose, code, visualization, and resources, such as source code, data, media. All of that can be packaged or linked to within the Jupyter Notebook itself. So this seems really good, right? This seems like, okay, Jane has done her experiment, we have this notebook, and it tells us the complete set of instructions of what went into Jane's experiment. So, what's missing? There are a couple things missing. One is that this is not really taking into account that there's a large conversation around how to use notebooks properly. So this is actually the intro slide from a talk that was given at JupyterCon in 2018. And he pitched the talk on Twitter as, "I don't like notebooks. I wonder if anyone at JupyterCon is going to say that." And they were like, "Why don't you come say it?" So it was pretty funny. It's a great talk. But basically, he doesn't have any qualms with notebooks themselves. They're amazing. I think that's almost universally agreed upon. His qualms are in how people use notebooks, and I think that's worth talking about. One of them is that notebooks have a lot of hidden state, right? So what can happen is that I can run cell 2, and then I can go back and run cell 1, but because I've run them out of order, it's no longer clear how information flowed through the document. And this, depending on how you're using it, this may or may not be something you run into, but this is something that it's really important to be aware of as you start writing these things, that having in mind that if you run cells out of order, weird things can happen and you may not catch it, is something that's really important. So I would like to add one more thing here, which is respecting statefulness. So we can do magic in Jupyter Notebooks, and we can also respect statefulness. This is something where it just means thinking about how you use a Jupyter Notebook. A lot of people will use them as a scratch pad, and I think it's really, really like a nice environment to start with, but you know, it gets dangerous there if you want to keep scratching on different elements and you start doing it out of order. So there's some really nice ways that I've already seen instructors here use. One is just to kernel restart and clear output, or kernel restart and run all. So you can see that if I go back to my Jupyter Notebook and I click on kernel, it'll tell me restart and clear output or restart and run all. And what that means is it just clears out all your variables and it just runs it again. So this is a really nice way if you're doing an analysis and you think you've got the whole thing figured out. A really, really quick way to just be like, does it make sense? Does it flow? Is just to restart and run it again and see, does it work? Does it still give what I thought it gave? Or did I run something out of order at some point and lose track of it? The other thing you can do is to think about using tools beyond just the notebook. So the notebook is amazing and wonderful, but there's a lot of other things. The notebook is not everything. The notebook is one really amazing tool. So what else can we use? So let's go back and think. Maybe it's something we're missing from this idea of the actual article, right? So we need the complete set of instructions. I feel pretty good about that. I feel like having the code and the figures and the text, I feel like I've got the instructions. But we don't have the complete software development environment. And I think there's two different ways to think about this. And I think one way to think about it leads really nicely into Jupyterlab. So what is Jupyterlab? It's branded as the next generation Jupyter interface, which I feel like definitely needs a spacesuit of some kind, but this is sort of more of a moon. There's some sort of theme there. And then you may be familiar with it already, because if you go to hub.neurohackademy.org, Ariel has actually set up for this course where you have access to a Jupyter Hub, which is just kind of a centralized Jupyter lab. So everyone has a Jupyter lab environment that they can log into, right? Because Ariel took your GitHub, so you can log in with your GitHub. If you can't, let us know, because this is really amazing. So I'm going to go ahead and open mine in just a minute, but I wanted to show you this first. So this is one way to think about the complete software development environment, right? It's having all the tools available that you need to do software development. So now not only do we have the notebook, which is up here at the top, we also have a way to view our output. We have a script that we can actually import. So here you see it's Lorenz, so it says from Lorenz import this function, solve Lorenz. So you have scripting, you have a terminal, you have a console, you have the notebooks, you have markdown files. You have all of this available in one place. So now you can start to interact with all the different pieces and to be like, okay, I really want, this function in a script that it's linted and I can do everything, and then I'll just call it in the notebook. So then I can really clearly see exactly what I did and when. So yeah, so if I don't want to go here yet, I want to go back here and I want to go to Jupyterlab. So this is hub.neurohackademy.org for me. Let me see if it'll make me log in again. I don't think so. So it'll do a fun spinny thingy. All right, so when you start, you may see something like this, or you may even see something like this. So this area on the right is the launcher. And what this means is you can launch all of these different things. So for example, I could launch a new Python notebook. I could launch a new Julia notebook or a new R notebook. If we added more kernels, you could launch other notebooks. You can also launch consoles, you can launch terminals. So let's say I really want a new Python notebook, and then I also would really like a new Python console. I'm going to do Python 3 because it's great. And then let's say I really want it over here. And then I want something else too, actually. So this is great. I have my console, I have my Jupyter notebook, but I would also love to have a text file where I can write about what I'm doing. And I can just grab any of these tabs and move them and drag them to whatever layout makes sense for me so that I have access to all these different pieces that I need. So it looks a lot closer to what some folks are familiar with. So then I can hide the file browser just by clicking on this file icon here, hide or show the file browser. And so now I have access to a text file, a console. I can also get a bash terminal. Maybe I'll show you how to do that really quickly. You just do new, terminal. Boom. And then I can move that even here. So I can have all these different pieces that I need, and I can actually see, everything that I want to set up my software. The other thing that's really, really cool about Jupyterlab is it comes looking amazing, but it's also designed so it has a very similar notebook user experience, but under the hood it's designed very differently, and the goal is like Fantastic Four here. The goal is to be very flexible, to be easily extensible. So, for example, this is a Jupyterlab extension that was written for Draw.io. So if you want to make diagrams right in your Jupyterlab, you can add the Draw.io extension, and then all of this is available. So you can have a notebook, you can create the diagram to illustrate your point, save it, and then have it right in the notebook from Jupyterlab, never leaving. So that's really, really cool. And if you saw Slack, we've already added another Jupyterlab extension for our Jupyter Hub, which is amazing. You should add more as you find and love them. So here, there was one added just an hour ago for variable inspector. So now you can see what variables are defined in the namespace and what their value, what their structure is. So that's really cool. So there are lots and lots and lots, I can't even hope to say all of them because there are more coming out every day. Jupyterlab extensions. And if this is something you're interested in, Chris, again, who'll be here next week, is a really great person to hack on this with if you want to add something new to Jupyterlab that you think is really useful. I know there's one, for example, where you can set it up so that it looks a very specific reporting style framework. So then it looks, just the whole lab setup itself looks more like an actual report that you'd produce and give to someone. So that's kind of cool. Okay, so Jupyterlab is awesome because now it gives us not only the complete set of instructions, which we had before in the notebook, but now we have a complete software development environment. So now we have everything that we need, right? We don't only need a notebook, we need a console, we need a terminal, we need a text editor. Now we have access to all of those pieces in one place. There's one other way to think about what is a complete software development environment, which I want to talk a little bit about, because I think this sort of is really exposed by asking the question, how would I run this code? So if I had the complete set of instructions and I have this complete environment, how would I go about running it? What would that mean in this context? And just based on Jupyterlab and Jupyter Notebooks, it's a little hard to see exactly where that would fit in. So there's a really amazing project developed by Jupyter called Binder. So the idea here is to create shareable, interactive, reproducible environments from Git repositories. So I've seen a couple of launch Binder links circulated on Slack, but if you haven't, let me just tell you a little bit about Binder. So basically, the goal is to do this. So if you remember Jane, we still, she's written this paper, she's done science, the small work of doing science. And so what she'd like to do is make it so that anyone can come through, reproduce, check what she's done. So she's gone through, she's made this Jupyter notebook, maybe she's made it in Jupyterlab. It has all the different pieces that she needs and that anyone else would need to come along and run the work, in that it shows the code, it shows the outputs, it shows, her thought process. So if she pushes that to a public Git repository, which is great, so now it's under version control, what she could do is also describe the software required to actually run the notebook. So listing, there are different ways to do this in different languages, but in Python what's really common is a requirements.txt, for example, which just says what packages do I need to run this code. So if she lists, she makes the notebook available, she lists the configuration files, which let's say it's a requirements.txt, and then she has any links to resources. So the data is fetched from here, or this is where I got this media file. Then what she can do is use Binder to make it so that everyone in the world can now run and reproduce exactly what she's done just by going to their browser and clicking a Launch Binder button. So this sounds amazing, right? This sounds like truly like the next generation article. It goes all the way through. It has the complete set of instructions of what she did, and it also has the complete software development environment in that, maybe she designed it in a way where she felt very much like all her needs were met as a developer, but now that it's out in the world, it's got the complete software development environment that I would need as a user, as anyone who wanted to consume this. I would have access to all the requirements necessary, I would have access to the resources necessary, and I could actually be able to run this myself and check it even on my phone, which is really, really cool. So this is Binder's goal. But how does it get the complete software development environment? Because I've given you a requirements.txt and a notebook, and now you're telling me you can run it in a web browser anywhere. So I did want to shout out, because I know we've been talking here about Docker. This isn't magic. It's just tech that we all have either heard the name of or love or hate or, somewhere in between. Basically, all that's really happening is you take a repository that's available on GitHub, you take whatever their configuration files are, and then you convert that into a Docker image that can be deployed on the cloud and that folks can work with. So what's really cool about this is it kind of harkens back to some of the principles of Jupyter. So what I was saying about, having an ecosystem of open tools that people can use. Here, in order to make that happen, they had to adopt some sort of best principle guides, which I think are also really important to think about in writing your own work. One of these is that repos should be both human and machine readable. So this is, I know, unfortunately, we haven't had the bids talk yet, but it kind of gets into this same idea of standards, right? So it's a similar idea of not only should your colleagues be able to go and be like, oh, okay, I see this folder, I think she means the code's over here, and maybe this piece is over here, but if you have it in a really standardized way, where all the resources you know where to pull from, then a machine can come in and do the exact same thing. The other thing is, if you can, try not reinventing the wheel. So this is always good advice for hackathon projects, and I think software in general. There's a lot of really amazing specifications and standards that we can draw on and use, and that's exactly what Repo to Docker is using here. They were like, we don't need to make a whole new containerization thing. Docker does that really well. What can we take and use in our own work? And then support many language and interfaces, and also be extensible. So this is a similar sort of thing as Jupyterlab. A lot of goals in Jupyter is to make it for other people, to make it easy for them to come and plug in and do what they need to do. So if something in Jupyter isn't meeting your needs, then there's a whole community that'll be like, okay, what can we build? What can we make so that you can use this in a way that's useful for you? So assuming you've met these standards, what it can actually do is it can take your dependencies. So I said a requirements.txt in Python. Again, it also works for R, so it's install R. And you can set your dependencies in whatever language makes sense for your project, and then it'll go through and actually create this Docker image for you. So really, it's as simple as just having, like, here's a notebook, here's the actual requirements in install.r, and then because you have this in the standardized way, and because you have it in a way where other folks can follow along, then you can start to do all these different languages. So you don't even have, you don't have to do requirements.txt in Python, you can do environment.yaml. If it's a recognized standard that's already out there, then Binder can build on that. So this is another one of the cool things that Jupyter does really well, is to think about how can we use stuff that's already in the world, that scientists have already developed, and make it so it's easier to actually do science. Because the goal here is to have it in a way where you as a scientist can now write the actual article very easily. Yeah, and so this is just a few of the supported configuration files. If you're interested in details, I'd be happy to talk. But just to throw out, there are lots of options here. It's really just like the languages, kind of whatever you're using, whatever you're comfortable with. So what's really cool is that it's an open service. So you can actually go and look at its status. You can look at how much money they're spending, how they operate, and any incident reports they've had. And then I just wanted to show. So this might take a second or two to spin up. So this is one I've done, where I can just go and I can click Launch Binder. And there are lots of these. I'll show you a good few public examples in a minute. And what it's going to do is it's going to find here, so I had this IPython notebook, I have my data, I have the requirements.txt. It's going to combine those all together in a Docker image. So here it shows me the notebook, which is what it's going to load. And then it says that it's launching the server. So this can take a minute. I'm not going to wait for it. I'll come back to it later. But it's really, really cool that it's able to just spin this up right away, just from what I have on GitHub. And so then, if you wanted to come, I've definitely done this before. If you are on your phone and you wanted to check something, it's totally possible. It can be wherever you are, so long as you have an internet connection. Here we go. Cool. Okay, so then here you can see I'm doing a matplotlib magic. And I can just go through and actually execute the cells, and I can even change them. So I could change my separator here, which would not be super wise, but it is technically possible. So you can go through and interact with these notebooks just in the browser, and you can get all of the outputs right there. So that's really, really cool. Where am I? Here I am. Okay, so because this is this freely accessible public resource, there are some amazing things people have done with Binder. And they're kind of in keeping this idea of how would you write the actual article. Now that we have all of the pieces together, what can we pull in and what can we make from this? So there are interactive textbooks, there's Binder for Open Education, there's interactive dashboards. This one's really cool. So the one that, if you haven't seen it, I have to show because it's just amazing, is LIGO, which was this really amazing it's where we figured out about gravitational waves. So if you go to github.com/minrk/LIGO binder, so what they did, the folks at CERN did, was after, or I think actually in tandem with the gravitational waves announcement, they made a binder so that you could go through as well and actually see all the data that went into figuring out gravitational waves were a thing. And you can interact with it just in your own web browser, which is amazing. This is like such an amazing way to engage with science. Even from other fields, it's still like astounding that you can go and grab these things and do it. And having it in neuroimaging is, I think, really, really powerful for us as well. So again, I'm not gonna wait on it, but I do recommend you check this out. It's really, really cool. And there are lots of other cool examples. Oh, here we go. Amazing. Yeah, it's really long, but there are lots of really, really cool things in here. So, okay, let me get back. Switching between windows. Yeah, and then if you just want to kind of browse around and see what are some of the other things you can do, there are lots of kind of sources for that too. So I link out a few here. There are a few instructor tutorials, which I've already seen were converted into binders, so that's another good inspiration. And of course, anything that you can open in Binder, you could also open in Jupyterlab. So that's a really nice way to have access to it and be able, if you want to keep developing on it, you can open it in Jupyterlab, play around with it, write some new scripts, test them out, see how they go. So I think that's awesome. The other quick thing I want to shout out about this is that, so let's say we've now written the actual article, or at least we know how to write the actual article, right? So we know that we can use Jupyter to get the complete set of, or to record the complete set of instructions, and to record and then generate the complete software development environment and a place to run the code, which is pretty cool. So people have been like, this is amazing, seems like such a cool insight, what else can I do with this? And Binder itself is actually all open tech, so it's called Binder Hub if you want to deploy your own. And it's community driven, and anyone can come along and deploy their own. So there have been some pretty amazing things that people have built with Binder Hub, and I think this is sort of like the next generation of the next generation. So this is stuff I'm really excited about, and I think it's pretty cool if you're interested. The first is Pangeo. So Ariel, unfortunately, had to leave, but is a really good person to talk to about this. Basically, this is a geosciences effort, so it seems a little weird that I'm talking about it at NeuroHack Week, but the reason is Pangeo is this really amazing effort built using Binder Hub, and basically what they're doing is there's this data set in geological sciences that's too large to move to geoscientists. It's just a huge data set. Much as I remember, I'm not sure if you guys ever experienced this, the Human Connectome Project would literally mail you hard drives, right? Like when you get to a certain amount of data, it's just really hard to transfer it. And so geoscience is in a similar situation, but rather than mailing hard drives, what they decided to do was to create a Binder Hub where the data was. So now what you can do is just, if you're a geoscientist or if you're not and want to play around, you can go to Pangeo and it'll launch up this Binder Hub. It'll look like a Jupyterlab, which is really cool because then you have access to everything. And it also has this really huge data set available directly. So you can go and play with that data set and do really cutting edge geosciences research right in your browser. It's like the state of the art. And the reason they can do that is because they took the Binder Hub tech and then they continued to improve on it and they plugged in this data set. So I know there's a lot of interest and some initial efforts into developing this for neuroscience. So that would be really, really cool. I think there's efforts around large data sets. Some of the data sets actually that Ariel showed earlier this week. So this is a space that I think is really, really exciting and definitely worth watching out for. And yeah, just again, that they're just customizing and configuring what was already there, and they're adding in some new high performance tools and this new data set to make it so that it's this really complete environment. The other one I just wanted to shout out, so I know Kirsty isn't here, but there's also something she's been working on, which is the Turing Way. And so this is this really cool, lightly opinionated handbook for reproducible data science, and it's run actually on a Binder Hub as well. It's actually where the adorable Jane diagram comes from. But you can go to theturingway.netlify.com and it will look like a web page, or it'll look like a textbook really, but you can interact with it, and what's running behind the scenes so that you can interact with it is a Binder Hub. So it's making it so that you can go and kind of survey best practices of data science in your browser and play around with these results and learn these different principles through it, which is really, really cool, I think. Okay, so the thing I did want to say too, especially because this is NeuroHack Week, and I think there are some people with amazing skills here who might be interested in some of this stuff, is that Jupyter is somewhere where it's really, really amazing and easy to get involved. So they have this discourse, which is kind of like NeuroStars, but just for Jupyter. And they're really, really passionate about helping new people get started, and if there's something you're interested in developing or learning or using in Jupyter, this is a really good place to go. And they also just have a really broad community where they have, so I've talked about Binder, Jupyterlab, and Jupyter Notebooks, but there are a lot of projects coming up in the Jupyter world that I haven't had a chance to talk about. So Voila is one that I think is really cool, and that's where you can create interactive like dashboards, all from Jupyter Notebooks. There's also Jupytext, so you can write in Markdown and it'll convert into a Jupyter Notebook for you, which I think is kind of fun. So those are just shouting two out, but there are lots more that I can't cover, and there are lots of people who would love contributions in any of those things if this is something you're interested in. And with that, I just want to thank all of you for your attention. Chris did make his own Party Parrot conga line, so this is courtesy of Chris. And he's also, so I'm unfortunately leaving on Friday, but next week for the hackathon, he'll be around, and he's a really, really great resource for Jupyter if you're interested in hacking on that. All right, thank you all. What questions? Yes?
I know this wasn't really a concern I need to have, but I don't necessarily understand the economic model behind all this.
Yeah.
It seems like there's a lot of logistics here that are coming out of nowhere.
Yeah. So like, how is Binder sustainable? Is that the question?
Like the computational resources, the hosting, and all this stuff, it seems like it would cost a lot.
Yeah, no, it's a great question. Yes, it does cost quite a bit. They even make their billing available. So it's like you can go and be like, oh yeah, this costs quite a bit of money. But they do have some really good support. So they actually just recently started the Binder Federation. So it used to be there was just one binder in the world at UC Berkeley. And now if there's a second binder in France at OVH. So they're distributing the cost that way. They also have support from Google. They have support from the Moore and Sloan Foundations. They have support from a number of sources of folks who are really interested in continuing to do this. But I think the other side that they're really encouraging is for folks to make their own binder hubs. So this is something I know Kirsty has done. We've been working on it as well in trying to do it on Compute Canada. But as folks are interested in taking this stack, and if they want to deploy it out on their own hardware and make sure it runs faster or whatever, they can take on that cost. This is just making sure there's always at least some based compute available. So that's nice. Yeah, great question though. What other questions do people have? Yeah.
So what integrate this with reference? References?
Yeah, great question. So the question is, what if I want to integrate this with a reference manager like Zotero or Mendeley or anything else? So I would say there's a lot of people thinking about this. I'm thinking about this quite a bit right now. So the current recommendation I would have is that what Chris and I actually have been working on is something called Jupyterbook. So the idea is that you take Jupyter notebooks and you make them look like a scientific paper. And so once you're doing that conversion, then you can think about, okay, I also want to convert all these BibTeX entries. Like I want to make it look like these are actual references that are converted over. In the Jupyter notebook itself, there's no concept of that right now, but maybe that's okay, maybe that's not. It's sort of like a how do you want to use it exactly way. But the way I think about it is that you'd write it all up in the Jupyter notebook, and then when you convert it to a PDF or a web page or whatever you'd want to submit, then those references would get carried over as well. So, yeah. But it's something we're very actively working on. So if it's something you're interested in, let me know. Yes?
Have people previously used Jupyter notebooks to submit to a journal, or is there a motion to maybe have papers that are Jupyter notebooks?
So I love this question. Okay, so let me repeat the question. The question is, have people already submitted Jupyter notebooks to journals? And is there any motion to do that if it doesn't already exist? Is that, you're right? Okay. I love this question because this is something we're working on and thinking about. So JB and Pierre, who's somewhere, and a couple other folks and I have been thinking about this in the context of something we're calling NeuroLibre, which is maybe a way to at least review notebooks and have some kind of review on, like a technical review on them. So we do have NeuroLibre notebooks right now, but I think in terms of what's been done so far, I would say I've definitely seen a lot of people include Jupyter notebooks either in the paper directly or as supplemental. We're still not at a point yet where journals will accept a Jupyter notebook as your main kind of input. And there are different ways to think about that, but yeah. No, I think it's a really promising thing. And then, sorry, JB.
I think you guys was released something that you could try to see that.
Yeah.
I think the best can actually publish as real publication thing.
Yeah.
Multiple objects, then look to one object. Data set is value. That's within the HBM work, but that's the average project.
Yeah.
And the NeuroHackademy project is I have a notebook kind of question to do this project. Let me check first that actually right. It's visible. Make it available for people to actually run. That would be our DAO project.
Yeah. Yes. Yeah. So sorry, just to restate to make sure everyone heard. Yes. So there's eLife, which has been doing Stencilla, which are reproducible documents. So it's not based on Jupyter, but it's another example of the same idea. And then also so NeuroLibre is really geared around notebooks, but there's kind of a recognition when you start to think about this that there are a lot of scientific objects that we produce that we don't really consider research outputs at this point, even though they are. They just don't get DOIs and they don't go on your CV, and it's a recognition that we need something like that is leading to initiatives like Aperture within the OHBM community. So yes, I think there's a lot of movement on thinking about how we can directly publish these things. For now, I see it mostly as supplementals and ways to encourage people to interact and engage with your work. Yeah, great question. What other questions do people have? No? Okay, thanks everyone.